Hi everyone. So in this lecture we'll discuss the pseudocode to check if a number is prime or not. Okay. So let us recall the flowchart that we have drawn to check a number is prime or not. Now let us try to convert this flowchart into pseudocode. Okay. So first step is read n. So it's okay. Read n. The next step is to initialize I as 2 because we are trying to find out a divisor in the range 2 to n minus 1. So we say okay. Let I equal to 2. And here we check, is I smaller than n? So here we also see that this is a part of a loop. This part is done repeatedly. We check while I is less than n, or you can do while I is less than equal to n minus 1. Both are fine. So here what you're doing, you're repeatedly checking. Okay, so for a number n, you're checking that is there any divisor in the range 2 to n minus 1. So the value of I is going from 2 till n minus 1, that is less than n. So what you're checking here, you're checking is n divisible by I. So you will put a if here. Okay, so this is not a loop, this is the starting point of the loop. This is if n is divisible by I, if n is divisible by I, then what you can do, you can simply say that this number is not prime and you can exit. This is what we have seen. So we can say print not prime and we can say exit. As soon as we get one divisor, we can say this number is not prime and we can exit. Okay, so for this while loop we have the stopping criteria, we have written the work that needs to be done, we have done the initial condition. So what is left is the update condition. Okay, so if n is not divisible by I, then go to the next I. Okay, that is basically this step, add 1 to I. So it becomes I equal to I plus 1. Okay, I equal to I plus 1. Now if you come out of this while loop, that means you could not find a divisor in this range 2 to n minus 1. If suppose you get 3 as a divisor of n, you would simply hit the exit. But if you are now coming out of the loop, that means you have scanned all numbers till n minus 1 and you could not hit exit. That is why you are coming to this line. So here you can say print this is a prime number. So basically this direction. So if you come out of the loop, you can say okay, that this number is a prime number and now you can hit exit. Your program is complete. Okay, so now let us dry run this for an example. Let's say 7. So what happens, you start from 2 does not divide 7, you make it 3. Okay, so you go to 3, so 3 is less than 7, 3 does not divide 7, you make it 4. Okay, so you come here again, 4 is less than 7, 4 does not divide 7, so you come here, you make it 5. 5 does not divide 7, you make it 6. 6 is less than 7, but 6 does not divide 7, you again come here. And finally, you make it 7. The value of I is now 7, which is not less than n. Hence, you end up at this line and you say, okay, 7 is a prime number. And that is true. 7 itself is a prime number and then you exit. Talk about a number like 9. Okay, what happens about 9? So you start from I equal to 2. 2 does not divide, 2 is less than 9. 2 does not divide 9. So you come here, you make it 3. 3 is less than 9, but 9 modulus 3, this is equal to 0. And hence you print that 9 is not prime and exit. So writing an exit here means nothing below exit would get executed and that is the end of your program. Okay, so that is how you can draw a flowchart and write pseudocode to check if a number is prime or not. Okay, so a quick recap of what we have done. So we start from, let's say, read n, we say I equals to 2, while I is less than n, keep on dividing. Okay, so if n is divisible by I, then you can say okay, this number is not prime, so print not prime and exit. Otherwise you go to the next location, I equal to I plus 1, and if you come out of the loop, that means you could not find a divisor, you can simply say print prime and then you can exit. Okay, So that is the complete pseudocode for this program. Thank you. I hope you have understood this logic now.